Okay, now working with the three prior functions and a little different dynamic in terms of volumetric determination. Okay, we have y is equal to the square root of x, y is equal to 0, and x is equal to 6. And this time we're looking at determining the volume of the solid generated about not either the x-axis or the y-axis, but instead about the line x is equal to 6. So in terms of what we have, once again with our general construction, okay, we have again we have the radical function y is equal to the square root of x, and then we have the vertical boundary x is equal to 6, and then we have y is equal to 0. And for a two-dimensional view upon which the solid is going to be generated, again it's going to, this half or this portion is going to be mirrored on the other side of the boundary x is equal to 6. And now in looking at integration, okay, we will be doing this about the variable y. Okay, and so we will be looking at altering the radical function y is equal to the square root of x and changing this in terms of x equals. So upon squaring both sides, okay, we're going to have that x is equal to y squared. Again, we have y is equal to 0, x is equal to 6. And for key contact points, okay, we have the boundary x is equal to 6. We now have x is equal to y squared. And we have the base y is equal to 0. And of course we have for the activity going on, okay, we have from 0, 0 to 6, 0 to 6, square root of 6 is our points of contact. And now, and what we have in generating the solid about the line x is equal to 6, again we have two halves that will mirror, and you have noticing x equal to y squared, and the whole triangular region is in perpetual contact with the line x is equal to 6 and mirroring on the other side. And since we have perpetual contact, we're going to preserve the use of disks. Okay, and so for what is going to be the radius in this particular case is going to be the width of this particular triangular region. And so think of it along the lines of integration over y. Think of the right hand function minus the left. To the right is x equal to 6, and to the left we have x equal to y squared. So the radius is going to be the width, which is going to be at 6 minus y squared. And as we look at the solid that is going to be generated, okay, almost something that is almost hemispherical in shape. And for what we have in terms of the solid itself, okay, we drew out the disk in advance, and we have again the radius we have at 6 minus y squared, and this is just a disk among an infinite many others from the solid, okay, that from top to bottom, okay, is going to be bowl shaped. And now for the volume that is going to be generated about the line x is equal to 6, we're going to integrate over y. So we have at the base y is equal to 0, and we have the top of the function, or the top portion of the triangular section, is going to be at y is equal to the square root of 6. So for the volume that we're going to have in looking at the use of integration about y and using the method of disks, okay, we now have okay, the volume we have going from 0 to the square root of 6 for y. And we have pi times the square of the radius, which we have at 6 minus y squared, and this will be taken to the second degree. And as we follow through, the square of 6 minus y squared, okay, is going to be at 36 minus 12y squared plus y to the fourth, and multiplied by pi, and integrating from 0 to the square root of 6. Okay, for what we're going to have to come about, okay, is going to be once we use the power rule of integration, okay, is going to follow that we have for the volume we have pi times the quantity of 36y. Antiderivative of negative 12y squared is going to be negative 4y cubed. For y to the fourth, we have y to the fifth over 5. Again, as y proceeds from 0 to the square root of 6. And so in distributing the numbers, okay, at the lower limits, okay, the value of the expression is going to be negligible, whereas for what we have in the square root of 6, we have the volume is going to be pi Then we have 36 times the square root of 6 minus 24 times the square root of 6 plus 36 times the square root of 6 over 5. And if you take 12 times the square root of 6 in the difference, or 60/5 times the square root of 6, and add to that 36 times the square root of 6 over 5 and multiplying by pi, we end up with the volume in the exact amount of 96/5 pi times the square root of 6.